Okay, this is part 2 of chapter 1, lesson 1. Let me adjust that down a little bit. And I'm going to take a look at some properties of real numbers, a couple of vocabulary words, and then some look at absolute value. So let's take a look at some of the properties or some vocabulary first. Some vocabulary you're probably familiar with, but something I want to make sure you know. And the first one is what we call the additive inverse. Okay, so this is what I want you to know, additive inverse. And what additive inverse really means is the opposite of a number. So if I give you a number and I ask you what's the additive inverse, I'm looking for the opposite. And remember, the opposite is simply putting a negative sign in front of it. Another way to look at it is numbers are opposites. How do I know they're opposites? What's the proof that they're opposites? And actually, the proof is that when you add them together, it is equal to 0. And that's how you can actually prove that numbers are opposites. So what's the opposite or the additive inverse of 7? Well, the additive inverse is -7. And how do I prove that? Well, because when I add 7 plus -7, I get 0. So because the sum is 0, these are called opposites. So that's the mathematical definition of additive inverse. So make sure you know that vocabulary word, additive inverse. We also have a multiplicative inverse. Ooh, multiplicative. That's fun to say. That's from ELF for those of you who are ELF fans. And the multiplicative inverse, another way to look at that is what we call the reciprocal, and you've probably heard this word before, reciprocal, and that is when I take a number like, let's say 1/7, the reciprocal of that is I just switch places with these. So this would be 7/1. That would be the reciprocal. So I just flip it over. And if I have a number that doesn't have anything underneath it, like let's say I had 7, well, I can always put it over 1. That gives me my fraction, and then I can go ahead and flip it over 1/7. Now, just like addition, we can prove their opposites by adding them and getting 0. We can prove that numbers are multiplicative inverses of each other, or reciprocals, by if we multiply them together and we get an answer of 1. So you'll see if I took this 1/7 and I multiplied it by its reciprocal, I can pre-reduce because it's multiplication, and then I have 1 times 1, which is 1/1, which is just 1. And same thing here. If I multiply these together, these reduce, and then when I multiply them together, I get a sum of, or a product of 1. So those are a couple of vocabulary words that you need to know. Let me go ahead and do a couple quick examples. I will actually do another video, I think, where I actually do some lesson problems so that you can see how these work together. But let me do a couple in this video. So what would be the additive inverse? Remember, additive inverse means just the opposite. So what is the opposite of -7/2? Well, you just change that sign, so it'd be a +7/2. And what do I get when I add a -7/2 to +7/2? That equals 0, so I have the additive inverse. So here, whenever you have something like this, you want to imagine parentheses around this. What would be the additive inverse? Remember, it has to equal 0, so really I just put a negative sign in front, and I take the opposite of both. So the opposite of pi is -pi, and the opposite of a -3 is a +3. So actually, if I add these together, -pi and pi would be 0. 3 and -3 is 0, so I actually get 0. So again, we just take the opposite of everything when we have something like that. Okay? Now, let's look at multiplicative inverse real quickly. Let's pull this example out. Whoops, don't want to do that. Let's point this. Here we go. All right. So what's the multiplicative inverse? Remember, the multiplicative inverse is when I switch numerator and denominator. Now, this one doesn't have a numerator and denominator. However, I can put it over 1. Remember, I said we could do that. So now I just flip it over, so I have 1/pi -3. So this is all together. So again, I can prove this, that when I multiply this together, this whole thing is going to reduce with this whole thing, leaving 1 and 1. And all that multiplied together is going to give me a 1. Okay, so multiplicative inverse and additive inverse, make sure you know the vocabulary. All right, so let's look at the next thing is some properties of real numbers. And I'm going to cover these really quickly. They're not something we're going to do a lot with, but something that you kind of need to know. And what these words mean, and I'll run through them quickly, but don't worry too much about them. Closure simply means that if I add A and B together, if A and B are real numbers, the answer is going to be a real number as well. And multiplication, if A and B are real numbers, then the answer that I get when I multiply them together is going to be a real number as well. That's what closure means. In other words, if you're using real numbers to begin with, you're going to get an answer that's a real number as well. You're not going to get these imaginary numbers that I talked about earlier that we'll talk about later this year. Commutative, you remember, you can reverse the order and still get the same answer. Addition and multiplication are commutative. Remember, subtraction and division are not commutative. Associative means I can group these together, so I can add these two together first, then add C, or add B and C together, and then A. Multiplication is also associative. The identities, didn't talk a lot about them, but these are important. The identity, the additive identity is 0, because when I add 0 to any number, I end up with the same number. Okay, so it doesn't matter what I add. As long as I add 0 to it, I end up not changing the identity of the numbers. That's why it's called the additive identity. What would be the multiplicative identity then? What can I multiply by a number and not really change the number? Well, I can multiply it by 1. So 1 would be the multiplicative identity. Inverse, we already just talked about. Opposites, when you add them together, equals 0. The additive inverse is the opposite of the number. The multiplicative inverse is the reciprocal of the number. And then the distributive property, we can distribute this into here. So those are some properties that we use with real numbers that you're probably familiar with. Now, I want to spend the remainder of my time talking about absolute value, because this really is the most important part, I think, of this lesson as we move forward, because we're going to be doing absolute value a lot. Now, probably in your earlier mathematics that you've had, you kind of know how to simplify an absolute value. In other words, you're probably told that absolute value, the answer to the absolute value is always just the positive number. So the absolute value is -3 is the positive 3, and the absolute value of 3 is 3. You always end up being positive over here, and that's probably what you've been told. And that's true. There's nothing wrong with that. However, as we go deeper into the subject of absolute value, we really need to think about it in a different way. And the way we want to think about it is this. Okay, so get this down. Absolute value is the distance from 0 on the number line. That's what absolute value actually means. What we're actually asking when I put this absolute value sign, I'm saying the distance from 0 of whatever is in here is, and then I usually have a value over here. Okay, so I really want you to concentrate on this, and I really want you to get this down. Absolute value is distance from 0. Now, the other thing that I want you to remember or to note here is that distance is always positive. In other words, when you measure the distance of something or the length of something, it's always positive. You can't have negative distance. You can go 3 miles north, or you can go 3 miles south, but it doesn't matter which way you went, you're still going 3 miles. And you can be 3 feet tall. You can't be -3 feet tall. You can be 6 feet above ground or 6 feet below ground, but either way, it's 6 feet. One is above, one's below. The length or the distance is the same. So another way to think about absolute value, and I already popped it up here, you probably saw it, is it's talking about the bigness or the largeness, or what's the value of the number. What's the actual value of the number? And I think the easiest way to think about this is to think about money. If you have $300 in your savings account, you have $300, it's yours. Now, if you owe somebody $300, you don't have it, you owe them $300. Now, is there any difference in size as far as having $300 or owing $300? No, it's still $300. It's just on one hand you have it as a savings, it's a plus for you. On the other one, it's $300 and you owe it, so it's a minus for you. But it's actually the same size. It's $300 no matter how you look at it. And that's kind of like what we're talking about. We're talking about the absolute value of something. We're talking about how big is that thing actually. Now, when we go to simplify these numbers in your absolute value, we always just simplify within the absolute value sign first. So like parentheses, you want to go ahead and just simplify what's in there and then go ahead and take the absolute value of that number. So for instance, if I had -1 times -2, well, I want to simplify what's inside here first. -1 times -2 is +2. And then I can go ahead, what's the absolute value, or how far is 2 from 0? Well, it's 2 away from 0. Okay? And so we want to simplify inside the parentheses or inside the absolute value sign first. Now, I'm going to talk a lot more about absolute value later on when we go to process these, but the biggest thing I want you to get out of this lesson is that it's the distance from 0. And there's one more thing that I want you to remember. Distance from 0. Well, I can go this way to get away from 0, and I can go this way to get away from 0. So if that's the case, how many answers do you think are going to be produced when we're talking about absolute value? I'm going to ask you that question. I want you to think about it and write that down, an answer for that, what you think it is, and we'll talk more about it in the next lesson. Okay, so that's the end of this lesson. Go ahead and attempt the problems from your homework, and we will see you in class.